Swayam Prabha. Digital India. Educated India.
Good day and welcome to this class in which we will be focusing on liners for landfills. If you recall, last time we discussed a lot of planning of landfills, and today we will focus on one of the components which we have to design, and that is the liner at the bottom of a landfill, which has to ensure that the leachate does not percolate into the ground. Before we do that, let's do a quick recap. And last time, as I said, we were discussing planning of landfills, and I'd like to very briefly look at this aspect of shape of landfills. I had shown you a below ground landfill, an above ground landfill, and a combination of the two. And these are what are adopted on flat ground. If you have a ground which is not sloping or not a low-lying area, not a valley, then your landfill looks like this or this or this. The important point I want to make, which I perhaps did not make last time, was that these are vertically exaggerated diagrams. Please understand. This is the width of the landfill, so this can be very large, and this is the depth. This is limited. As I told you, typically this will be 7 to 8 meters in unsupported excavation if the water table is deep below, but this width can be large, and for municipal solid waste landfills it can be several hundred meters, or it can be a kilometer or two. In hazardous waste landfills, which are a little smaller, which are smaller than municipal solid waste landfills, this dimension can be a few hundred meters. So if I want to look at this in the correct dimensional perspective, I come here. So I've just taken the scale that this is about 500 meters long, and as I said, typically the height will be restricted to 15 meters, so that's 15 meters, and here the depth has been restricted to 7 meters. So these are thin, spread out waste repositories on the surface of the ground. When you have a valley, then they'll be high. And when you have a side slope, then also they can, the dimensions will be significant in height. But typically on flat ground, they are thin elements. Now here I have got B equal to 500 meters. B means the width. And if you look at it, suppose I own 500 meter wide land, which has got a width of 500 meters. I actually own everything beneath that boundary, and I own everything above the boundary. Or is it not so? I don't know. What are the laws? If I have a plot of land, do I own everything under the plot and everything above it? No. So somebody said I don't. Why not? Who owns what is below my ground? So there is soil beneath my feet. Who owns that soil? If I wanted to build an underground building which was 5 stories deep, can I build it? So unless there is an underground utility or a resource or a commonly shared resource, then if it is not there, you can go as deep as you want. Similarly, if I want to go up a kilometer into the sky, if I want to make Burj Khalifa, once I own the land, I own the airspace above it. Unless you are coming in the flight path. For example, the IIT main building cannot be higher than what it is because it is on the landing flight path. So we are 8 stories or 9 stories. Suddenly if we wanted to make a 25-story tower here, we can't do it because you are on the landing path of the aircraft. So if there is a common resource being used, then I can be restricted. So every person who owns a landfill site wants to use it to a maximum capacity. However, I told you height is restricted from aesthetic considerations. 15 meters high means how many storied building? 3.5 meters to a story typically, so maybe about 4. So you don't want your waste dump to rise above the skyline of the city, so typically 15 meters high and 7 meters deep from excavation considerations. However, if I have only a 100-meter width, and you didn't ask me, sir, what is this S height? S is the side slope of the above ground portion. If I have 100 meters, then I have a problem. I may have the same area. This may be a square configuration and this may be a very long configuration. But the problem is that this is my airspace and I'm using very little of it. Not even 50%, not even 33%, I'm using very little of it. And the other problem is I can't go as high as I want. Because it's 4:1, you only have, this is 100 meters wide, you only have 50 meters as the horizontal width, and the height that you can get if you start from the extreme boundaries is 50 divided by 4, which will be 12.5 meters and not 15 meters. This is a critical aspect of landfill capacity. Okay. The other thing which I wanted to talk to you last time about was the estimation of landfill capacity, and we talked about waste generation W tons per year. We talked of N years as being the life of a landfill, and we said total waste in N years is W into N. So I also mentioned that this is a very approximate formula. In fact, this is an underestimation because your population is growing or decreasing, and you have to do a correct estimate. And at first I asked you all to come up with some figures about this waste generation per capita per day in various cities. So you must have discovered this by now. So in India, what kind of figures did you get? And in another country, what kind of figures did you get? So anybody would like to give me some figures which you came across? So Mumbai, we have one figure. Now we are talking of kg, 0.63 kg per person per day. Anybody has any other Indian city? Bangalore. You mean Bengaluru? If you got a figure of 0.39, is it very recent or old?
2005.
Oh, 2005 is very old. Your data is for which year? No, no. I mean, sure? So if this is 2005, I can say that this is like if you put money in your fixed deposit, what will happen to it after 5 years? It will double. So you may like to give me a more updated figure. Anybody else has a more recent figure for any other city? Which year? So you have the same source? Did you go to Wikipedia? Okay, great. Did you go to CPCB or Ministry of Urban Affairs? Which website did you attack to know that this is correct? Anyways, I think very revealing, but we are above 0.5 kilogram per person per day in the metro cities. So anybody has got now figures from overseas mega cities? हाँ जी, आपने किया है? बताइए. Tokyo. Okay, what was the figure? 1.38. Do you have the year? And do remember, Tokyo is an island in Japan. I mean, we are in Japan, which is, waterlocked. You don't have much space. They want to keep minimum waste because you don't have much area to dispose it. They don't have too much land. Anybody else?
1.24 in 2011 in Tokyo.
So that's fine. I mean, that's fine. So we are reconfirming 1.27 in 2011. So it seems to be recent. Any other major city in Europe or Paris? Okay. 1.50 to 2.00. You have the year?
This is 2012, 14, sir, all the data combined in the range.
2012 to 14. Okay. Anybody in America?
1.16.
Where? London. Give me US. Yeah. Okay. New York.
2.75.
Anybody would confirm 2.75?
So 4.5, sir, 2014.
4 point?
5, sir. It is highest polluting city in the world.
4.5 is a little bit high.
Sir, in pound. The weight is in pound.
Sir, no, sir, not pounds, sir, kg. Sir, even two, three papers they have cited 4.55.
Wow. So somebody said 2.76. So we'll say 2.76 to 5.00. So all that I want to say is this is a huge variation. But clearly the more developed the country, the higher the per capita output of waste. So I wanted you to get a flavor of this. As we go into rural and smaller cities, these values will reduce. As we become more prosperous, we consume more and therefore more waste comes out. So our footprint no longer remains small. So just to end this discussion, we did this W into N, but we have to remember W is not constant but increases with time for two reasons definitely, as population increases and as per capita waste generation increases on account of increase in GDP. So future population can be estimated as current population into 1 plus y over 100 into n, where y is the rate of population growth in percentage. India, it appears to be 1.2%. Japan has minus 0.1%. Germany has wavered on both sides of 0. It was a little low earlier, now it seems to be picking up, but these are estimated rates and it depends on the time span. So one is the population will keep on growing. The second is that the waste generation rate will depend on what it is today plus the rate of GDP growth. There seems to be a correlation factor alpha. So we don't want to get into great detail on this, but there seems to be a direct correlation between waste generation. Even if your population is constant, if your GDP per capita goes up, what's the rate of growth of GDP in India? 6 to 7%. So this is going to go up, right? So basically what you need to do is for future years, you have to look at the future population, you have to look at the future WG for the ith year, and for each year you have to compute it and you have to sum it for your n years. So this is an underestimate. Really, this is an underestimate. But this is just a very simple way of looking at things. The third thing I wanted to talk about in planning, which we discussed as we were closing last lecture, we talked about the closure and the post-closure plan. And our idea is that the landfill component should continue to remain functional till the closure period, post-closure period is over, typically 30 years. We must achieve the ended use. And suppose the ended use is not golf course or parking area, then we have to restore it to its original condition. And I would like to address this a little more in detail. If you are making a golf course or a parking area, it will be commercially maintained. right? You'll be getting an income, you'll be maintaining it, you'll be able to monitor all the signs of settlements, of something, leachate coming out from somewhere, if at all. So you are able to, but if you are not going to be there, then how do you restore it to the original condition? Of course, till that time, we have to remove the surface water, we have to do the maintenance, and we have to do the periodic inspection and monitoring. So conceptually, this is what the broad picture of landfills is. We found a location which nobody was using for disposing our waste. We cleared it up, we put a liner, and we put our waste in daily cells, then yearly phases, and then when it was all over, we had a covered landfill. And in terms of covers, everybody wants a green cover. Nobody wants a concrete cover, nobody wants a black cover. You know, all your water tanks are black. Remember Syntex water tanks? But then people said, if black doesn't look good, let's have white. And then you started getting pigmented and different colors of water tanks. So if this is grass and if this is the waste, we have to monitor this for 30 years. And if we have to walk off, two things have to be assured, that this is stable. It is no longer having bad emissions. That's number one. The second important aspect is grass cannot survive by itself. You know, you have a garden, you have a park. Grass survives because it is irrigated. There is a mali. The horticulture people are looking after it. They have beautiful hedges. But vegetation in the wild survives by itself. So native vegetation is self-supported. That means if there is a monsoon and then there is a summer and then there is the winter, the vegetation may go from green to brown, and it may not be visible for some time, but it will sprout again. So that means that vegetation survives without being given additional irrigation water or fertilizer. So our aim is that if the waste inside this has become stable, before I leave, I have to get the natural vegetation back on this. Because if I don't, what will happen? The grass will go after I walk off. Once the grass goes, the binder to the top soil goes, erosion will start, and then progressively this will deteriorate. If the waste is not stable, that means if the emissions of the gas and the leachate are not within the acceptable limits of the Pollution Control Board, we can't leave this site. And I've told you this, then we have to take other measures after the design period as to what to do about it. But this is what we are saying we will do in restoring it to its original condition. So here we have homogenized or harmonized the waste with the surrounding environment. Okay? So this is the larger picture. Immediate picture, of course, is to how not to pollute the environment. But can we really walk off a site? So if you see, most of these cycles are 50 to 100 years, industrial areas. If you look historically, industrial areas start becoming degraded with time. We were not taking adequate measures, our land was becoming polluted with time. So before you could reuse the land, you had to rehabilitate the land, you had to remove the pollution. So this is exactly what we are talking about. So any questions on this aspect about the planning aspects which we discussed? There's 2-3 fine points. Otherwise, we can start with liners. Great. So I believe we are all on the same plane, and we would like to see that we are looking at the bottom element which prevents the leachate from going into the ground. Depending on the type of landfill, I mean, you may have more cover or less cover in comparison to the liner. Both are impermeable elements, a cover and a liner, in the dry tomb concept. If it's a below ground landfill, you can see the liner is more than the cover. If it's an above ground landfill, then the cover is more than the liner. And if it's a side slope landfill, then the cover and the liner appears to be similar in the quantities involved. The major difference between the cover and the liner is that both are impervious or have very, very, very low permeability, but the liner gets buried. It's not accessible. the cover is always accessible for repair. So the risk of leakage here is much higher, and therefore this has to be, we have to be very careful about the design of the liner. And as I've already said this earlier, this is just a figure which will keep on coming again and again. The cover is a multi-component, multi-layer device, and the liner is a multi-component, multi-layer device. As we go forward, this will begin to make more and more sense of all these details. So what are the functional requirements of the barrier in the liner system? We have a hydraulic barrier. So the first statement is it should be impervious. So as I said, I am not aware of any impervious material. I am not aware. Eventually a liquid will pass through, if not by gravity flow, then by diffusion, by a sheer push at the molecular level of the difference in concentration. Even a plastic sheet which looks impermeable to us, eventually a gas comes out of the plastic sheet because you can, under concentration and pressure differences, have something moving out. Very, very, very slow. Our objective is simple. Whatever comes out of the landfill is like whatever comes out of a factory. As long as the emissions are less than the permissible values, we are happy. So when we say it should be impervious, what we mean is it should be very, very low permeability. Everything has a permeability because nothing is a solid matrix. And the other thing is that it should remain intact under settlement of subsoil. Now as you build up your waste, you're passing stresses onto the ground, the soil will settle a little, and therefore whatever you put at the bottom should not be a rigid element which will crack. Right? This is more important in covers than in liners, because in the cover the waste itself is settling, so the settlements are much larger. But that does not take us away from the fact that the subsoil is also settling, and God forbid if you are surrounded by loose or soft soil, then maybe the settlements can be high. So your containment system has to remain intact. Over and above this, it has to remain functional for 50 to 100 years. So it is not like, I can put araldite. You know what's araldite? No. What kind of glue are you using nowadays? If you have to stick two pieces of wood together or a plastic, something breaks, what do you use to put them together, to join them? Louder, I can't hear you. Fevi-Quick. Okay, so everything has to be quick. So my araldite or Aral-Quick, that's what I meant. So the point is, you can join something, but if that material with which you join it with time shows some kind of shrinkage or cracking, then it's not the material that we want. So we must be sure that the material with which we are working will remain for 50 to 100 years. Like we are sure about bricks, like we are sure about concrete, we are also sure about the reinforcement bars, but sometimes when there's a lot of seepage of water, then corrosion does occur and it does cause spalling. But we do know that cement, bricks, concrete, these are materials which will last for 50 to 100 years. So we must have that, and these should not be affected by leachate. Now, the leachate can be of various types. You can have leachate from a municipal solid waste landfill, you can have a leachate from a hazardous waste landfills, and you can have a leachate from a construction and demolition. So the intensity of the concentration will change and also the constituents. So it should be able to withstand the leachate. You see many times concrete floors, if you go to chemical factories, if acid is falling on it, a pH is high or low, it starts to affect the flooring. So we need to have a material which is not affected, and it should not degrade with time. There should be no degradation of the material, like ultraviolet stability, sunlight or oxidation. What example can I take? If you have a plastic chair and if you leave it in the sunlight for a long time, the plastic becomes more and more rigid and more rigid, and one day it cracks. Maybe this happens to your hostel chairs as well. If you have a hose pipe by which you use for gardening your water, and you leave it in the sun or leave it in the open, not even in the sun, with time it becomes more and more stiffer, and then you eventually it cracks. So these are not materials which are remaining stable with time. And oxidation is a big culprit. When we are talking of something for a year, that's fine. But when we are talking for something for 100 years, then we are worried about oxidation. And you and I are getting oxidized. Is that right? To live longer, what do you have to have? Antioxidants. So first we are breathing oxygen, and then we are saying we are getting oxidized. So everything gets affected eventually in a very slow way by oxidation. So these have to be stable against oxidation for this period, and should not show long-term cracking. That means works fine today, doesn't work fine after 10 years. That's not all. There are many more things the liner has to do. It should withstand the load due to moving men and machines. You are going to spread a liner in a football field, and then you are going to spread the waste. Well, maybe the dozer will not directly move on the liner, but there will be a layer of waste. But people are moving on it. The people who are spreading the liner are moving on it. So it should not be damaged by moving men and machines, and it should not be damaged by the stresses coming on account of 15, 20, 30, 40 meter high waste. This should not get. Should be easy to construct. Now there are two types of materials, those which are prefabricated and those which are constructed on site. And this is typically the problem in your in situ construction versus prefabricated construction. Prefabricated construction, brilliant. Everything in the factory, perfect temperature, pressure, pH, humidity, everything comes out wonderful. On the site, it depends on the mood of the operator, of the labor, and if he's not in a good mood, God help, the quality of joints is going to be that much different from what he does all the time. So we prefer prefabricated stuff because it's better quality, but when you get prefabricated stuff, it is of a limited size. Whether it is cloth, whether it is polymer, whether it is a bituminous sheet, all these may come in the form of a roll, but still it is limited size. Whatever is being done in situ is not limited in size, except if you want to stop working. For example, when you put the roof of your house, how many of you have been involved in the construction of a house, either in your BTech project or your father's house or your grandfather's house? How many of you have actually seen a roof being cast? One, I can't believe it. Two, okay, many of you. So what is the critical thing about the roof? When you cast a roof, when you're doing concreting of a roof, and I'm talking of RCC roof, what is the most important thing? It has to be completed in one go. You can't say, I'll put half the roof today, I'll go home and sleep, have a hearty meal, and I'll come and do the other half of the roof tomorrow. I can join the two. There's not an issue that the material will not join, but you will get a joint. So when you do in situ construction, you can make as big a thing as you want, provided you are working 24/7. So in situ construction requires that there be no cold joints, no construction joints, no abrupt stoppage. See what will happen. Suppose I do a roof in one go. I started in the morning, it didn't complete by the evening, I put on the floodlights, I got second shift of labor, the concrete kept on coming fresh and moved forward. The back part of the concrete was setting, the front was fresh. Now, if another guy doesn't do that, he says, okay, I'll take a break, I'll come after 8 hours. This concrete has set. The new concrete is fresh. You can chisel around and make the contact intimate, but always between the fresh concrete and the old concrete, there will be a joint. That will become a preferential path of seepage. So, should be easy to construct with existing technology. If you are getting prefabricated, then they should be joinable. If you get something which gets damaged, then it should be repairable. I mean, you are working with a plastic sheet, your screwdriver falls, you get a hole in the plastic sheet. So you got to repair it. And some people say it should be self-healing. I mean, you forget to heal it, it should heal by itself, like your wound. You have a self-healing wound, you have a small cut, you forget about it, you're all right. So do we have self-healing materials? Maybe they'll be biotic, maybe they may not be biotic. Should be amenable to quality check after construction. You can always say, sir, I have made an impermeable barrier for you. I don't believe you. I want you to prove to me that it's leak proof. So if you have an overhead water tank, it's above the ground. If it leaks, you'll get to know. You'll fill it up with water. But if you have a liner below the ground, you can't go under the liner to check the leakage. So it should have on-site leak-proof checks, quality control tests. Should not slip along slopes. In liners you have slopes, in covers you have slopes. It should not be something which slips, and in the end it should be economical. So this may not be that important, but between alternatives which satisfy all the above, you should take the most economical alternative. So now I've given you the boundary conditions. Now you tell me the materials that we are used to using for being hydraulic barriers. As I said, we are making a hydraulic barrier. First, we are not going to look at cost. We are not going to look at cost. Just tell me the materials which you think function well as hydraulic barriers. Clay. Clay is not impervious, it is low permeability. Anything else? Oh, you have all the money. I'm going to give you $1 million. Money is not a constraint. Let's look at the best materials that we can use to meet all our requirements. Concrete, okay. What else? I mean, everything which your water tanks are made of is a good indicator that if water tank can hold water, quite clearly it is a hydraulic barrier. So what else? Plastics. Metal sheets. I mean, many of the basements, if you will go, they'll put aluminium sheets next to the retaining wall so that the water doesn't come in. So metal sheets. So we've got steel tanks, we've got concrete tanks, we've got plastic tanks. We don't have a clay tank, okay, but these work. Anything else? What kind of sealants, water barriers do you use in dams? What kind of water barriers do you use for waterproofing? And we are just going to look at all the civil engineering materials with which we deal, so see which one is the one which can help us now. You know DPC, damp proof course. What do we put on a damp proof course for preventing the water to rise up the walls? No, we don't put aluminium sheets in a damp proof course. PCC also is not impervious. You know, if you again I asked you, were you involved in construction of a house, a room? If you are not, go and watch the construction which is taking place next to the LHC on the, as you approach the LHC on the left side, something is being constructed. So I don't know what they do for DPC nowadays, but in my time they used to put something which was black. Bitumen, coal tar, whatever you want to call it, that was waterproofing material. So bitumen. So you get these so many waterproofing magical things for walls and basements. Some you can put by a brush, some you can spray. Aren't these magical things? So let's put magical things at the bottom. Others. And these can be epoxies, these can be resins, these can be sprays, these can be brush-ons, these can be emulsions, so all kinds of stuff used on walls. Used on walls, roofs and floors. So these are the various alternatives. Let's now see what can work and what cannot work. Clay, what's the problem? It's not impervious. It has some permeability and water will eventually come out. It can. Anything else? It has some low permeability. That's one problem. Anything else? Can it take the stresses? Can it take the stresses of a 30-meter high waste dump? Or will you have a bearing capacity failure? I don't know. What about concrete? Concrete also has low permeability, probably lower than clay if it is well compacted, well vibrated. But what is the other problem with concrete? Is it flexible or is it rigid? It is not likely to take settlements. Is clay likely to take settlements or will it crack? Concrete will crack. I mean, so PCC will crack, RCC will also crack. We can design uncracked section of what size? I'm trying to put a concrete floor 500 meters by 500 meters just for you to get the idea. This is 5 football fields in this direction and 5 football fields in the other direction. So that just about puts us in its perspective. Maybe it's the size of all those lawn tennis courts that you have between the hostels on that side. So PCC will crack. I can't make an RCC slab which is that wide. I have to give joints. I have to give construction joints. So the moment you give construction joints, it's no longer a problem about the impermeability of the slab. It becomes a problem of the impermeability of the joint. Or you can always put all kinds of water stops and sealants, but joints are more difficult to seal than the parent material. So there are issues of low permeability, rigidity and joints. Plastics are almost impermeable, almost, but they also have low very, very low permeability, much lower than clay and concrete. But do plastics have some other problems? Yeah, so these are puncture, tear, so, and they also have problems of joints because plastics will come to you in rolls. So what is the widest width of roll that you can get to a site? 3 meters. So there is a suggestion that it is 3 meters. Well, one thing is very clear. I would like as wide a roll as possible because then the number of joints goes down, right? So how much is the widest roll? There are 2 limitations: how wide can you manufacture and how wide can you transport. तो किस में transport करोगे आप? I have this great simile that the space shuttle. I've done this with you before. If I have, let me know. Okay, so the size of the space shuttle the width and the diameter is governed by the size of the backside of a horse. And what is this interlinkage? You have a space shuttle, and it has to be put together. So the jets are made somewhere else, the chambers are made somewhere else, the payload at the top is made somewhere else, and all these have to come together at one place, assembled, and either you assemble everything at the site or they have to come from somewhere. So that means everything is governed by transportation. How do you transport things? No, I don't transport anything by a horse. Not nowadays. When Sherlock Holmes used to be there, if you're watching the serial, then you used to go in a lovely horse carriage way, right? But today it'll either come in a truck, or it'll come by ship, or it'll come by a helicopter, or it'll come by a train. 4 modes: by land, by water, by air. So the helicopters can only lift this much and bring it along. So I think the propulsion jets of the space shuttle are sent by rail. So you can have a narrow gauge in India or a wide gauge, or maybe even a wider. But once you are sending something by rail, its size is fixed by the size of the rail track. You can overflow a little bit, but you can't send a hugely wide. You can't take this room on a railway wagon, right? So whether you send it by road, then you have to go beneath flyovers. The size is limited. You send it by rail, you have to go through tunnels. The size is limited. You try and pick it up by helicopter. Well, I don't know how many helicopters will pick up this building. You have the payload issue. You can send it by ship, sure, pick it up by crane, but does the ship reach where you want to launch it from? It may not. So if you're going by train, always remember that the width of the track, what governs the width of the train track? A road is of variable width, single lane, 2 lane, 4 lane, 6 lane. Expressways have how many lanes? Four this way, 4 that way, 5 this way, 5 that way. You can have 8 to 10. So what's the width of a road? It can be as small as 3 meters when you're going to a village, and it can be as wide as? Okay, 3.75. You can be as small as 3.75 meters, and how wide can an expressway be? 50. Don't bother. I mean, the Gurgaon toll probably 50 meters wide. How wide is the rail track? Where did this come from? Why did they make this rail track 1 or 1 point something meters wide? I mean, who fixed this? Or why didn't they make it 3 meters wide? So you have to go back historically. What I understand is that when the rail came, before that the mode of transport was the horse with the carriageway. 2 horses put together used to pull a carriageway, right? So the width of the wheels of the carriage, cart or carriage was decided by the width of the backside of 2 horses standing side to side with sufficient clearance. So when they started to put the rail tracks, they had to put it in areas where there was no road, but only horses used to go. And horses, not the ones which went without a rolling carriageway, because then they could go in any which way because they have a hopping motion. So the rolling carriageway went at grade, slight incline. So all these were already laid out. So the tracks were put in the impressions of the wheels of the carriage. So the size of 2 backsides of 2 horses governed the width of the carriageway track, and on it went the rail, and that's our rail track today. Of course, there must be other considerations why it didn't become wider with time. But eventually, the propulsion jet of the space shuttle comes on a rail track, and therefore the maximum diameter that it can have is governed by the backside of a horse. because if the backside of a horse had been larger, the rail track would have been wider and you would have been able to put a more wider propulsion unit on the train. So the same thing applies here. I want to send in a huge roll. What is the length and what is the width of the roll? So if I am sending it by truck, then the width of the roll is, I can put the roll lying down. So there are certain limitations. So plastics, we said tear, puncture, joints. But one can always make a plastic which is going to be puncture and tear proof. And a very simple example is my shoe has a top, your shoe has a top, right? And you walk in it, you play in it, something falls on it. Does it puncture? I'm not talking of the sports shoes which may have cloth, but if you have a leather shoe or a plastic shoe, then you will notice that the top of a shoe will last you for 4 or 5 years, or maybe 3 or 4 years. You agree with me on that? If I drop a screwdriver on this, maybe my toe will break, but my leather will not have a hole in it. So if I make the plastic sufficiently thick, I can definitely ensure that it may not get damaged during installation. Because if these were to get damaged every time I hit something, then I'd have to buy a new pair every few days, and we do hit it across ever so often. So please remember, we can take care of this issue about being tear and puncture. Okay, metal sheets, no problem. They are also flexible to some extent. But again, there's the issue of joints. And currently, metal is more expensive than plastics on a performance basis. So there's the issue of cost. Bitumen, wonderful material. Clay is prefabricated or on site? Yeah, it comes from a borrow area, but it is spread on site and compacted on site. Concrete is prefabricated or in situ? In situ construction. Plastics, prefabricated, they come from a factory. Metal sheets, prefabricated, they come from a factory. Bitumen. Bitumen comes to you in drums. The main element of bitumen is it has to be heated. Once it is heated, it's liquidy, you can spread it and then it sets. So working with bitumen is difficult. Given a chance, would you be working in an asphaltic plant laying roads, or would you be working on a concrete roof? Given a chance. Suppose you have to work 10 hours a day just installing or constructing with bitumen and constructing with concrete. Which would you prefer? Working at the ambient temperature is easier than working at an elevated temperature. So issues are of quality control. When you work with hot material, the issues of quality control, right? So bitumen is good, it's flexible, and because it is in situ, the issue of joints doesn't come. You can keep on spreading it as long as you want, or you can also get it in the form of sheets. So bitumen is both. You can get bituminous sheets. For example, you have these bituminous sheets for putting on your rooftop. They have a plastic or a polymeric base on which the bitumen is already pre-spread, and you can roll it out and heat it and join it. And bitumen is easy to join. You can heat and join, heat and join. So bitumen is flexible, joinable. It is also prefab, but it is hot, and not hot as in hot and happening, hot as in hot and burning. Otherwise you get a lot of these words which are used. Others. So other than these materials we have others. So what about all these waterproof paints and waterproof sprays and waterproof liquids. What about them which are used in walls? So these others work well on a strong plain substrate. I mean, if you want to paint something, you need a wall. Would you like to paint something on soil? What will happen? I ask you to paint, okay, this is soil, please paint some impermeable liquid on it. What will happen? You will take a brush and you will paint it. What will happen?
Some will get painted, some will not, some will seep down.
Why will it not get painted?
Granular material, so it will not like connected to each other.
What you are trying to say, I think, is that when you will put the paintbrush on the soil, instead of the paint going to the soil may get stick to the paintbrush. That's what you are trying to articulate. The substrate is not strong and uniform. So you can't paint anything on soil. The soil might want to paint itself onto the material that you are trying. So you may not be able to transfer it to the soil. So all these things, which are these magical resins, polyurethanes and waterproofing compounds, they work well on walls and floors and roofs because the base is very strong and you can spread them very thin and very uniformly. On soil, there are two problems. You don't have a plain, thin, flat finish. You just don't have it. I've already told you, you want to use an earth moving, you want to use a dozer to make the bulldozer to make your ground flat. Well, it is only that flat. It's not like flat as in the bathroom floor where you can give an inclination of 1 in 1,000. Our flat will be undulating flat. So that's first issue, that you don't have a perfectly horizontal. And the second issue is that the soil particles, especially if you try and think, can I put paint on sand? No. Can I put a spray on sand? Yes, but the moment you put your foot on it, it will just displace itself. So these all don't work. So quickly, we worked with water storage tanks. You can have concrete steel polymers. In canals, I use concrete. I also have brick lining. I have clay. I have polymeric membranes. The word plastic, I am using polymeric here. Dams and barrages, we have concrete cores, concrete for stopping the water, clay cores, asphaltic membranes. Roofs and basements, concrete, waterproofing materials, asphaltic membranes, asphalt. So as I said, concrete, rigid, thin, in situ construction, joints, cracks. Steel, aluminum sheets, rigid or flexible, thin, prefabricated, joining on site, quality of joint and costs. Clay, flexible, clay has to be thick. You can't put a few millimeters of clay and say, I've got an impermeable barrier. So it has to be thick, means it has to be in terms of meters. In situ compaction, it has low permeability, but it gets shrinkage cracks. So when you see this, when a drought comes, all these periodicals and magazines will show a farmer sitting on a dry field, and you'll see these hexagonal patterns in the soil, and those are shrinkage cracks. And the dry lake bed on which he's sitting is the clay at the bottom of a water pond. When it dries, it gives you shrinkage cracks. But do remember, these cracks are reversible. They are self-healing. If you take a clay which has shrunk and you give it water, what will happen? If it can shrink, it can swell. So these shrinkage cracks do close themselves, and therefore they are reversible. This is an important thing because one of the great negative aspects highlighted in clays are shrinkage cracks. And you feel, oh yeah, this crack is 5 millimeter wide, all the water will go down. But the fact is, every time a lake dries up or a pond dries up and rains come again, all the water doesn't go down because the cracks heal. So they have a self-healing capacity. Polymeric membranes, flexible, thin, prefabricated, they have to be joined on the site. The issue is about the quality of the joining, the puncture and the tears. Asphaltic materials, flexible, thin, construction at site or prefabricated. Quality of construction, they also require strong base, and you have to work in a hot environment, which I have unfortunately not written here. So maybe I would like to add that. So hot working temperature, waterproofing materials, flexible, thin, application can be done on site, but they require a strong base. So quite clearly, I am not, are you able to get one material which you can use? From all that we have discussed, what we have written here, do you have one material which you would like to use? You would like to use plastic. And then you will assure me that there will be no tears and no punctures, and when you join these things together, the joints will be 100% leak proof. Well, unfortunately, I have not seen even one plastic installation where there has been a perfect waterproofing. It's like, you know, you have this, the vegetable vendor, he'll have a thin plastic sheet, the blue one. But if there's one pinprick in it, the water will keep on coming out from that side. So what it appears is that, what experience shows is that with thin polymeric membranes, leakage through punctures or tearing, even if we take the maximum precaution, there will be some holes. So this gives you fast seepage. You make a puncture in a plastic sheet, water will come out very fast. Problem with thick clay barriers here, they are not totally impervious. There may be some heterogeneity of the clay. There may be some shrinkage cracks. Therefore, you will get slow seepage through large areas. So the answer to our problem is a composite barrier. We do not use one material at the base of a landfill. No single standalone material. We are talking of a polymeric membrane in intimate contact with a clay barrier. That's the liner that we use. There may be some holes in the geomembrane, but the moment there are holes in the geomembrane, they'll be stopped by the clay. And try and use a geomembrane of significant thickness to prevent puncture or tear. But even despite that, you get punctures or tears in the field. So let me first come here. This is what the composite barrier is. Typically, we use a high density polyethylene geomembrane which is 1.5 to 2.5 mm thick. This is pretty thick. And it rests on a clay which must be at least 1 meter thick. It must be compacted, and the permeability is specified. It should be less than 10 to the power of minus 9 meters per second or 10 to the power of minus 7 centimeters per second. This is called a composite, single composite barrier or a single composite liner system. And just understand the fundamental principle. It's very important for you to understand. You have a geomembrane and I put 2 pinpricks in it and all the water will finish, which is standing on top. There's no way it can hold water. You put a clay barrier, water will not finish, it will always remain on top, but it will come out drop by drop eventually. Eventually it will come out. I put the geomembrane in close contact with the clay. Please understand, intimate contact. Then what happens? The large area of the clay, no water is coming. This through the pinhole water comes and it is stopped by the clay. So rapid seepage through small holes, slow seepage over the entire area, very slow seepage through small area. So all this which doesn't have any puncture, the clay will not allow any seepage, and where there is a puncture, the clay will inhibit the seepage. So this is the concept of the system. And remember, many people install this wrong. This is correct. You have a clay at the bottom and geomembrane at the top. If you don't have intimate contact, please understand what's happening. Suppose you have sand in between or you have an air gap. What happens? You have a hole here, the whole thing becomes filled with water. If the whole thing becomes filled with water, you again have water over a large area and the entire clay will seep. So critical to this is that if you have a hole here, then the water should not be able to travel laterally under the surface of the geomembrane or of the polymer. The clay should be there immediately. So need intimate contact, and that's called a good installation condition. So I just again bring this back to you. The most critical thing not written here is the intimate contact. If there's a little bit of air gap or permeable soil in between, you'll have a problem. Okay, I'd like to try and wind up now. A single liner system means it's not composite. It has one of the elements, right? It may have clay, it may have geomembrane, but it is not composite. A single composite liner, so please understand single liner systems are different from single composite liners. Single composite liner is what we saw, clay in intimate contact with geomembrane. You can have a double liner system, two walls or two polymeric, you have double walled overhead tanks, an inner wall and an outer wall, but they are not double composite liners. Double composite liner means repeating the element. And quickly I bring your attention to the bottom three diagrams. This is a single liner system, only clay. Maybe it will be used in a C&D landfill. This is the waste. There is a little bit of sand and pipes which we will explain next time what they are. But the waste rests on clay, it's a single liner system. Not used for municipal solid waste landfills, not used for hazardous waste landfills. The minimum requirement for municipal solid waste landfills is a single composite liner. There must be a geomembrane in close contact with the clay. And the minimum requirement of hazardous waste landfills is a double composite liner. Please distinguish between double liner and double composite liner. What is a double liner? If I put one clay and one clay with a drainage layer in between, it's a double liner. But a double composite liner, or if I put one plastic sheet, a gap and another plastic sheet, that's a double liner, but that's not a double composite liner. A double composite liner means one composite liner here and another composite liner here. So this is typically used for hazardous waste landfills, and this is typically used for municipal solid waste landfills, and such a system can be used at C&D waste landfills. So let me revisit what I was saying. We don't use single liner systems for landfills except for C&D or inert waste. However, single liner systems are used in canals. You put plastic sheets in canals, you use it in ponds, you use it in lakes for drinking water reservoirs or water reservoirs. Single composite liner systems used in landfills. Double liner system not used in landfills, but maybe used in double walled underground or overhead tanks. Double composite liner system used in landfills. So these go for hazardous waste landfills and the others go. So I'll leave you with these diagrams. We will discuss what this is, but this is the leachate collection layer. We always said there will be a straw on top of the liner. So we have a sand layer here or a sand and a gravel layer here. So if there is any leachate, it will be taken away by these pipes. So you have the waste, the leachate collection system and the liner. We are only discussing this today. Leachate collection systems we will discuss in the next class. So if there is any clarification or doubt in your mind that you would like to discuss, you're welcome. So we have introduced the concept of a composite liner, and we have introduced the concept that no single material is a good standalone containment system for 50 to 100 years. So with this we stop. Thank you.